Hello, Professor and/or TA who is watching this. My name is Johnny Manes, and I am presenting the video for our group. This does take a little bit, so I'm just going to run it now and explain as we go. So I'm going to start our server, and just a preference, we have tested that this does work with up to a total of 10 different clients or terminals. For the sake of speed and everyone's sanity, we'll do just 5. So we'll run the server and it will ask us how many clients we would like to run. So we're going to say 5. And as you can see, we are downloading the data set right now, which is our the fashion MNST one, I believe, from TensorFlow. So while that's doing that, we will go ahead and run these. For each terminal we run it on, we specify what port we want this process to run on. So for example, this device will do 8080, and we will go up in ports for the next 5. And you can see we're currently waiting for, the server is waiting for all the devices to load up. So it won't start until it has all devices, which we specified was 5, so 5. So this is our last one right here. So you can see we use ports 8080 through 8084. And now the server has received all those ports. So our project is a distributed federated learning process. And the distributed part about it is that instead of, like, for instance, how data parallelism for PyTorch or TensorFlow, it sends the data, like the data set itself, and then trains the model. We're not sending the data set. Each client has its own version of the data set. And what gives it its own version, because you can see here, oh, we're just downloading the same thing. Like, what's the difference? When we put this into a data loader object, which is, part of the PyTorch framework that we're using, we have this parameter or this field called shuffle true. And what this does is this shuffles the data set for every round of machine learning. So up here, you can see we've already done a couple, and we're doing that through all our devices. So each terminal or each client, quote unquote, is running its own machine learning process on this model, this untrained model that the server has sent. But back to my point is that each round of machine learning is shuffled. The data set is shuffled, so it's randomized. No data sets in each client is going to be the same. And to give a little more generic overlook of this, basically our server makes a untrained model. And in this case, we have a neural network as our model. And again, our framework is PyTorch. So everything we've gotten here is built from the PyTorch tutorials and just modified to our own needs. We have an untrained model. We send that to all of our clients, and all of our clients are going to run their own machine learning process on this model. Then the fun part is, and the decentralized part about it is, we're not sending data sets back. We're sending the model back to our server. And you can see right here, yeah, got it just right. We are receiving now 5 different models from each of our clients. So after, for instance, this one is done with its final epoch, and we're doing rounds of 5 and 5 because that just seemed to be the basic, most optimal way to get better results. We're sending our data back to our server. And what this does is, you can see here, we write it, no more data, and then we aggregate. And what that is this function here. And a big part of the federated learning part is we're combining all these models into one. So for each model that we get from our clients, we take 2 of them, we process them, we aggregate the results together to get one new model, and we send that back to, I believe it's our make connection function right here. Yeah, and you can see we're doing this n number of times for how many clients we have. And so we're just aggregating over and over again until we have one final model. And then once our server has that final model, it sends that back out to all our servers, so to all our clients. And you can see here we're doing another round of machine learning for all our clients. And this is because we sent them a new model, an aggregated model, And at the end of it, once this is all said and done, after we're doing 5 rounds of federated learning, each round has 5 epoch rounds, so each machine learning task is 5 rounds. After that, then we have our final model, which is the culmination of all these machine learning things tasks together. And after that, we evaluate it against our data set to determine if, in this particular instance, our model or our machine can accurately identify different clothing articles. So that'd be shirts, trousers, I believe ankle boots, whatever's really in there. So I believe we're on epoch 4 or 5. I tried to space it out as much as we can. But you can see over here on the left that for every client we have its own model that we save it in. That's just because since we're on one machine, there could race conditions could happen, and I know because it did happen, where we're downloading and also reading from the same file, and that obviously causes everything to crash and burn. And so in order to avoid that, we just make a new file based off the client's port. This was originally going to be run on Docker containers, but Docker is incredibly slow with this, and that would have been a much longer video. So I believe now we are entering the final stage. We're writing. Okay, we have one more. You'll know when we're on the final stage when all the clients are done and their processes have terminated. But I believe we're sending out one more round. Yeah, we're sending it to client port 8080, 8081. A little bit more background about our framework is we're using the PyTorch library, which also is, I want to say, not an extension, but it adds on to the TensorFlow framework. And all this is used to make federated learning a lot more easier and manageable. Yeah, if PyTorch is really good with different kinds of machine learning tasks. They have a bunch of different modules, specifically neural network ones, which is what we were using, just because it simulates a actual real life human brain and the way neurons connect and everything. A lot of these functions are asynchronous, just because that seemed to be the most efficient way to get this stuff done on different clients. We're using sockets and TCP connections in order to send everything, receive data securely and safely and reliably as well, because the last thing we want is to be downloading something and it be cut off halfway through and then our whole thing messes up. So I believe, yes, we are done now. So this is going to be the final and on the final task for the server, and it's going to evaluate, and you can see here predict sneaker, got sneaker, sneaker, dress. There are, obviously it's not perfect, there will be some variations, like for instance bag, but it was an actual t-shirt, but then we have bag again. So I want to say for every, this is about 10 or 11 predictions, I want to say we get 10 out of 11 majority of the time, which isn't bad in my opinion. Pretty good. Obviously the more epochs, the more clients you add, the more this will be, but again, just for the sake of this video, to keep it kind of short and sweet, we did 5, but it has been tested that we can do a total of 10 clients, as you see here. We did previously before the video. And yeah, that is it. Thank you so much.